Today we're starting part 1 of our exponent properties involving products. We're going to see what happens when we multiply expressions with exponents and how we can simplify them using a shortcut. In this first section, for each expression, we're going to expand out. Then we're going to condense back in to write one final answer using an exponent. Think about playing an accordion. Open your accordion as far as it will go, and then we're going to collapse our accordion back in. So x to the third means that we have 3 x's multiplying itself. X to the second means we have an x multiplying itself twice. So by expanding out all of these exponents, I've stretched out my accordion and I've written this in expanded form. Now what I can see is that I have x multiplying itself 5 times for a simplified version in exponential form of x to the fifth. Let's try one more together. For the first part of my number 1, I've got y to the third, which would mean I'm going to multiply y by itself 3 times. Then I'm multiplying this by y to the fifth, which would mean multiplying y by itself 5 times. Then I'm multiplying this by y to the second, which would mean I'm multiplying y by itself twice. By writing it in expanded form, I've expanded my accordion and stretched it as far as that would go. Now what I can see is that I have y multiplying itself repeatedly 10 total times. So if I compress my accordion back in, that would be a final answer of y to the 10th. For examples 2 through 6, write them in expanded form first, and then write your final answer using one exponent. Pause the video, press play when you're ready to check your answers. So in each case, when the variable is being raised to the exponent, I'm multiplying that variable times itself that many times. P to the fifth meant 5 p's multiplying itself, and p to the second meant 2 p's multiplying itself. All I have is p's multiplying itself, so I can express p to an exponent, and since there's 7 of them, it would be p to the 7th power. In this case, I had s to the 6th power because there are 6 s's multiplying itself. On number 4, when I expanded out, I had 12 m's multiplying itself. On example 5, after expanding out, I had 11 n's multiplying itself, and on example 6, after expanding out, I had 10 k's multiplying itself. Our next task is to look back at the original problems and see if we can come up with a shortcut to getting the final answer without having to expand out. So ultimately, what you're being asked is, could you jump from this problem to this answer, skipping over the expansion part? Pause the video, take a second, see if you can see a way in which you could do that. Press play when you're ready to check your answers. So if you noticed that, for example, 3, 5, and 2 can combine to get 10 if you were to add. 3 plus 5 is 8, plus 2 is 10. 5 plus 2 is 7. 3 plus 2 is 5. Don't forget that's a 1. That would be 6. 4 plus 8 is 12. 3 plus 6 is 9, plus 2 is 11. 7 plus 2 is 9, plus that extra 1 is 10. Then you've found the shortcut. The key is that when you're multiplying, which here the x to the 10th and the x to the 12th are being multiplied, as long as your bases are the same, in this case they're both x, the shortcut allows you to add their exponents. So x to the 10th times x to the 12th would mean x to the 22nd. And you can always visualize it by expanding it out. X to the 10th means 10 x's, x to the 12th means 12 x's. Expanded out, that would be a total of 22 x's multiplying themselves. So let's try the bottom using our shortcut. Pause the video, press play when you're ready to check your answers. So in each of these cases, I have the same base within the problem, and it's all multiplying, so I'm allowed to add my exponents. 3 plus 5 is 8 for y to the 8th. 6 plus 5 is 11, plus 1 is 12 for h to the 12th. 2 plus 4 is 6 for z to the 6th. 5 plus 11 is 16 for k to the 16th. 3 plus 7 is 10 for p to the 10th. This one's a little tricky. G to the 1st plus 4 would be g to the 5th. 5 plus negative 2 would be g to the 3rd. Later on, we're going to investigate the implications of negative exponents, but for right now, since it's multiplying, we can just add. So here we've got our new rule alert. And so what our new rule says about exponents is if we're multiplying and the bases are the same, so in this case I'm multiplying and both of my bases are x, I'm allowed to rewrite my answer as x, same base, to the power of m plus n. One little trick I like to use to help remind myself of this are When I'm multiplying, I'm making numbers bigger. Other things I learned when I was younger to make numbers bigger are addition, then I learned about multiplication, and then I learned about exponents. This one will come into play tomorrow. But for right now, we're multiplying because separating x to the m and x to the n is multiplication. So what I'm going to do is I'm at multiplication, I'm going to take a step back, which allows me to add my exponents. Let's practice this new rule. We're going to write our answer as an exponent for right now. So I can leave it as an exponent. That means that 7 to the third times 7 to the fifth would be 7 to the eighth. You try examples 2 and 3. Pause the video, press play when you're ready to check your answers. So for my 9, since I'm multiplying, I can add 8 plus 2 is 10 plus 1 is 11. For my b's, since I'm multiplying, I can do 5 plus 3 is 8 plus 2 is 10 plus 1 is 11. Let's try example 7. So on example 7, first thing I want to notice is that I've got some extra stuff. So I've got 2x to the third and 4x to the fifth. But what's important to recognize is that the only operation in this entire problem is really multiplication. 2 is multiplying x to the third, 4 is multiplying x to the fifth, and then I've also got multiplication going on here in between those two quantities. Now remember, multiplication is commutative, and so what that means is I can rearrange my order. So I could rearrange my numbers to come first, so 2 times 4, then my variables to come second, times x to the third times x to the fifth, because I can multiply in any order that I want. Now I'm going to multiply my two sets of numbers, 2 times 4, and I know that 2 times 4 is 8. Then I can multiply my sets of variables, and since the x's have the same base, they both have a base of x, and they're being multiplied, my shortcut that I just learned tells me that I can add my exponents. So that would simplify to x to the 8th power. And if I were to expand this out, this would mean 3x is multiplying itself, 5x is multiplying itself, for a total of 8x is multiplying itself. So this final answer would be 8x to the 8th. Give this a try on examples 8 and 9. Pause the video, press play when you're ready to check your answers. So on example 8, I showed the rearranging. So I did 3 times 7 first to get 21, and then x to the second times x to the 8th to get x to the 10th. Since I was multiplying with the same base, the shortcut tells me I can add the exponents. On example 9, I did the same thing. I just didn't rewrite the problem in this same order. I used my highlighter, though, to show you what I was multiplying. So first, I was multiplying my 5 and 6 to get 30, and then I was multiplying y to the second times y to the 7th to get y to the 9th. Since the y's are multiplying each other and they happen to have the same base, I'm allowed to add their exponents. Let's look at example 10. So again, the only operation going on in this entire problem is multiplication. There's multiplication happening between the 8 and the x to the 5th, between the x to the 5th, the z to the 3rd. There's multiplication here, here, and here. So I can rearrange these in any order that I want. So I could multiply first my 8 times 7. That would give me 56. Next, I could multiply my x's, x to the 5th times x to the 11th. Since I'm multiplying my x's and they have the same base, I can add their exponents to get x to the 16th. Then I could move on to my z's. Z to the 3rd times z to the 6th would be z to the 9th, for a final answer of 56 x to the 16th z to the 9th. Pause the video, try this with examples 11 and 12. Press play when you're ready to check your answers. You might find it helpful to use color like I did on the previous problem. So on example 11, I'm going to multiply my two numbers. 2 times 6 is 12. X to the second times x to the 5th. Since I'm multiplying with the same base, I can add their exponents for x to the 7th. Y to the 3rd times y to the 8th, same reasoning, would be y to the 11th. Final answer, 12 x to the 7th, y to the 11th. On number 12, I can multiply 5 times negative 6 to get negative 30. Remember, a positive times a negative is a negative. P to the 4th times p to the 5th is p to the 9th, and y to the 2nd times y to the 7th is y to the 9th.